Deep Learning course by Eugenio Colorcello. Today we're going to talk about what is machine learning. Machine learning, in the simplest definition, means make computer learn from data. It also can mean learn without being programmed, which is a bit of a misnomer, as I will see later. It can also mean learn a function mapping. So usually, if you have a function, for example, like a sigmoid, like here, a function is basically a mapping between inputs and outputs. If you do have such a function in math format, then you're done, because you have a relationship between the input and the outputs. But what if you don't have a function? For example, here is an image of a cat. Do you have a function that maps this input, this image, into the word cat, for example? There is no numerical function that we can write or express easily, right? So we saw that machine learning is basically learning from data, learn without being programmed, or learn a mapping function. So instead of, if you don't have a function, you can use the data to learn without being programmed necessarily, meaning I don't have to specify why a cat is a cat, but it can learn it from data. Also, another definition of machine learning, or goals of machine learning, are to imitate intelligent behavior. For example, here, this is a GPT, natural language processing algorithm, that basically you give him an input, like write me an article on creativity, and it will create. The word creativity is used and abused and so forth. So it looks like it's generating something that a human would do. It looks like it's generating something intelligent, although that will have to be defined later in the course. We can also think of replicating human abilities. For example, a self-driving car, where you have the ability, you've replicated this ability that we have of driving or doing some complex task. But we can also go beyond. Machine learning can go beyond the human abilities, and you will see that. For example, what if we could create a robot or a robot spaceship that could go further than we've ever been before, and explore, for example, the galaxies or the depth of our world or environment that we are not able to go in. Also, typically, machine learning is divided into a few types. And I recommend you just remembering this, because you'll hear it a little bit later in the course. First of all, we have classification. Classification in machine learning means you have a set of data, like blue dots or green triangles, and you're trying to figure out, whenever you have a new data, whether it belongs to the blue dots or the green squares. Is it class A or class B? This is classification. Then there is regression. Regression means figuring out real values, like in this example here, we want to find the slope of a curve that models some specific data. So we want to find the parameters of this curve, or a parameter of a function that basically approximate the data at its best. There is also clustering that you hear very often. And clustering is the kind of algorithm that figures out automatically groups of data, right? Which we don't have a name for. It's not exactly a class, but it's an unnamed class, basically. You will also hear very often in types of machine learning about supervised learning. So supervised learning uses a data set composed of examples, inputs and outputs, Just like, for example, here we have a picture of a dog and the label dog, picture of a cat and the name cat. And then we can learn some kind of classification, for example, based on this data set. This is supervised learning. Another big example, larger example of supervised learning is if we have a large image categorization data set. For example, we'll have thousands of categories and thousands of examples for each categories. And we want to learn this mapping. This was one of the very first deep learning success, almost 10 years ago. We also have unsupervised learning. Unsupervised learning is whenever you have a data set that has an input but it doesn't have an output. And that's because maybe it has not been labeled, or maybe you do not have this relationship yet. In unsupervised learning, for example, clustering, you can group inputs by similarity, let's say, or do some other tricks, which we will see later. Another example of unsupervised learning, for example, is image completion. We just have an image and we can block some areas and then we can learn to complete it. We don't really have a label here. There's also text completion, which is predicting the next word in a sentence. Like I've seen the word belongs to those who get up, and then I want to predict the next word, which is early. And this is how GPT, the model that you've seen before, is trained. So these are example of unsupervised learning. There's only an input, but there's not necessarily a mapping to an output. Although you can create one artificially, like in these cases. There's also reinforcement learning, which usually operates in a loop and tries to figure out things by itself. So you'll have an agent with a goal that may or may not have a goal, that performs some action on an environment, but it's also able to sense the environment in order to maximize that goal. And the agent has to create, generate actions, based on what it sees, generate another action until it reaches its goal. And reinforcement learning learns this by doing trials and error. An example of reinforcement learning, which you've also seen in the previous lecture, is a robot learning to pick up. Several robots here use reinforcement learning to look at their plates and plan the next move so that they can pick up a specific object. And this is it. These are some example of introduction to machine learning. I hope this is useful. We'll go into depth very soon.